Right, so now we're on centre height. What we're going to do now is make sure that the tool is square to the job, so it cuts a square thread. I mean, this tip was actually ground on a grinding jig, so I know it is square with a tool shank, which is square with the tool holder. But what you can do, right, this thing's called a fishtail. It fits. It's grounded at the angle. It's used as a grinding jig for grinding a tool as well by hand. That's square against a chuck. You can see it's not quite square. Once to do that, there. Right, so that's square against a chuck, and that V there is fitting in perfectly. So that means that that tool is at the right angle to cut that thread. It's square to the job. Oh well, that'll show up. Try it with another light on. Light underneath. You can see how it's fitting in the V perfectly there, and it's square against the chuck. I've showed you how we used this before when cutting external threads. Internal threads is just the same. The gearbox is still set up to cut with 24 TPI. I've had a look, I've checked. Nobody else uses a lathe than me. One thing I'm going to do, I'm going to put a little nip on the gibs on the cross slide, just to stiffen it up a little bit, just for cutting that, but that's nice, just for cutting these threads. The problem I had, I adjusted it, I had the lash height, I had it locked up when I bored the base, and it takes a while to get the feel of it the way you want it. It feels nice there. The backlash, there's 10 to a backlash in the screw, nothing to worry about. All the others have got backlash in them to a greater or lesser degree. Touch in there, so we zero the counter. And with this thread, it's a very shallow thread. Normally what I do is I set the compound slide angle across, and I feed the thread in just on the compound angle, cutting on the front of the tool. With a fine thread like this in soft material, you can get away with coming straight out and cutting it in one go. It means you're cutting both sides. The coarser thread, I would definitely angle the compound slide, but on a fine thread like this, you can get away with it, especially with a nice sharp. It's a really sharp tip tool. Right, so I set on 0. I want the lathe in a nice slow gear. I want my back gear engaging. Move my carriage out a bit. A lead screw engaging. It will start it up. Noisy bastard thing in back here. Right, what we'll do is we'll engage one note to make sure that the carriage is going the right way, which it is. Right. This thread, this 24 TPI is a direct relationship to the lead screw, which is 8 TPI. 3 is 24, so I can drop the nuts in on any whole number or any half number. What I'll do, I'll drop it in on whole numbers. I'll wait for 4 to come round. We'll put a little bit of oil in there. I'll zero that, so I'll put the 5 thou cut on. Coming round now, 3.5. Right, that's a nut engaged. Scratching the thread. Once it goes through, there's loads of room, plenty of room. Disengage it. Set the counter back to 0. When you're in one full turn, fetch it back. Counter back to 0. Put your cut on. We'll do a 10 thou this time. Get closer, I'll watch it for our numbers. There's number 2 coming round, that's a whole number. engage there. Forget what oil. Yeah, pick the same thread up. Once again, once it's through, zero your counter, in a full turn and back out. Out your counter to zero. Zero plus your 10th out cut. You must do it, you've got to do it the same way every time. If you're lost track of what you're doing, stop the machine and start again. It's dead easy to put an extra turn on, in it goes, off with the end of the tool. Right, we've got our 10th out cut on, a little bit of oil, watching for the numbers coming round, engaged. It's cutting out, no problem at all, nice light cut, I'm not in a hurry. It's a short thread. Once you get through, plenty of time, disengage that, set our counter to zero, in a full turn, and wang it out of the job. Back to zero, plus your cut, ready to go again. Right, we'll give it a try. This time we're away in. That's a nice thread. Not wobbly, pissy slack, just nice. Excellent. What I'll do now, I'll mount both the nuts on the shaft and I can skim the faces and drill some holes in. Right, it's back between centres. I've got the two nuts screwed on. All I'm going to do is take a finishing cut across there. See, they run nice and true, no piss wobbles. The outside face was never machined when we come to make the nuts. And we'll settle for that. See, it's hard to get a finish on soft steel. There's an emery tape, it's a short bit. Again, using a big long bit, it'll pull your hands in. It's a nice little bit. Just to break the edges. A bit of oil. What I'll probably do, I'll try mounting this. I'll mount this on the mill machine. I'll actually use the index and head to hold these while I drill them. That's nice. I drilled with pins so you get two locking pins in so you can put them on, take them off. I'm going to try and get the bastards off now. Not too bad. What had happened was as well that it actually got warm there with machining them and you want them getting stuck on the shaft. Right. And once again how easy it is to put something back in centres. Accurate. Quite happy with them. Before I did this I actually googled the thread, and 7/8 by 24 is a cycle thread that they use on bottom brackets on cycles. So whether the original one used ready-made nuts off that, I don't know. That's what it takes to make them. So there's little holes, 8 holes to drill in, 2 or 3 places, and you can put them together, set the clearance up, lock them up. If our nuts are going to be moving all the time, I would use something harder than mild steel, but they'll be set once and that'll be it. You just use what materials you've got to hand. Stainless would have been great, but I didn't have any. I've got none left. Right, I've got it mounted on a milling machine, as you can see. I'm going to drill holes in here for locking pins. I've got my wiggler in with 1/4 inch ball on the end. First thing I need to do is find the centre of that. This will give you some idea of how this thing will be actually worked when it's used for real. So I've got what I've done, I put the driving dog straight up and down, and I've locked that. Those are nipped together. The wiggler's on centre height. Set it away. I need to run things a bit faster because I'm going to be running small drills. That's better. So you don't use your hand to stop that, use something metal, it won't hurt that. Right, it's on centre height. You wind it out till it touches, it'll deflect it. That's it there. You know you're dead on the edge, so a 0 y-axis. When you cross to the other side, what you could do, you could use maths. Half of that ball's 125,000, half the shaft, you could do it that way. I'm going to do it this way. Right, once again, touch it and stop it spinning. Wind it in till it touches, and you just start to move it. That's it there. Got a reading of 23.45mm. I'll use metric, 23.45. Use inches, it's easier. 0.9 of an inch, 0.92. Half of that is 0.456. 0.456 because half of that, so we'll go that way till we get 0.4. 456, that's what's centre. Lock that off. Now what I normally do, set it away again. Use the centre finder God give you, your eyes. Set it up. Fix the camera now so you can have a look. Absolutely spot on, thinking of it. Right, next thing we need to do, we need to find that edge, face of that, so when you're in, so it just touches. That's it, there. Right, so it's 0 y-axis. Y-axis is 0'd. If we go that way, 125 though. $125. It's too accurate, this for normal. Look at it. Right, 125 though. That puts that right on the edge of there. We've taken 125 thou, which is half the diameter of the ball, which happens to be one full turn on most milling machine lead screws. So we know that that now was right on the edge of there. That's 1/4 of an inch thick. Each one of them is 1/4 of an inch. So the centre of that is 125 again. So if we wind this in and 0 that, another full turn, 100 and wrong way, you dozy bastard. I'm not worried about tens of thous. Right, 125. We know that should be right in the centre of there. So we want a centre drill, we want a hole in there. Centre drill. 250 that way. $250. Centre drill. Temptation is to grab that when it's spinning, don't do it. You might have seen me do it, don't. No jewellery, no gloves. It's a no-brainer really. Just touching, lock that off. 0 Z-axis. For the oil. Gently, 200 thou cut. Back to 0. Bit of oil. Just starting to cut down to 0. That's excellent. It's actually working backwards because this is a bit of change wheels go on. But if I loosen this clamp off and I turn it, the latch lying horizontal, it means I can put 2 more holes in, which will be roughly 90 degrees from those 2, and I can do it again. I can do it 4 times. You can appreciate now when you've got a gear on or a gear train with a locking pin in, you can have the multiplications. There's nothing, I wouldn't think there's any number you couldn't divide by. So if you're cutting gears, you'd have your gear blank on there and you'd turn it round. Right, so you can see how it works. 1, 2, 3. They're all in the same place on the nut, and they're approximately quarter of a turn apart. So if you had a gear on, you could index them and get them absolutely spot on. My little tool will just go in there like that and screw them off. So well, as much as I can do on this now, I need to get the casting done for the banjo that the gears are fastened onto. And I can machine that down from your gears. There's a keyway to put in and some more threads on the end. Anyway, thanks for watching. Happy with that, are you?